I don't know. We move on to something happier now. I got an email from Stellenbosch University. They have a very active media department in the sense that they are always alerting us to interesting and groundbreaking work that researchers and people studying at the university are doing, and it's absolutely fabulous to get those emails because I do like highlighting innovation. There's lots of it in this country. We spend a lot of time on this program talking about the many negative aspects of our social and communal and economic and political and criminal life. And it's wonderful every now and then just to remind people that there are South Africans doing amazing work in all sorts of disciplines. And this one was about the Centre for Human Performance Sciences, which has initiated, I was told, a new research project in partnership with Timetronics, which is the world-leading commercial provider of athletics timing equipment. To tell us more is Gareth Patterson, a researcher at the Centre for Human Performance Studies, CHPS, so I wonder if they're called CHPS. He's on the line to us from Amsterdam, where he is doing some work for his PhD. Hello, Gareth.
Hi, how are you doing?
I'm doing very well. Yourself?
I'm good, thanks.
What is this research project about?
Well, specifically the centre has been developed along with myself, colleagues Grant van Velden, Warren Adams, Melissa Hillhouse, where we basically fall under the centre at and we have a sports technology unit. And within that sports technology unit, we have certain technologies like high-speed cameras, etc. And one of the latest pieces of equipment that we've got is this, what we call the FAST system, which is force, acceleration, speed, and time. That's basically the FAST abbreviation. And what we've done is purchased the system and have been training up with it and using it for the last 6 months or so. And it's the world-leading testing and training device now especially coming up to the Olympics 2012 that we're using with athletes at the Olympic level and lower, where we are able to test them and get so much detail about the 100-meter sprint specifically. We can do for 200 as well, but you'll be surprised within the 10 seconds or 11 seconds that people run how many variables have to be exactly right for them to be able to run these times. So basically, yeah, that's where we stand with this system, and at the moment we are the only ones in Africa with the system.
Yeah, unfortunately we don't have anybody who's in with a serious shout at even a semi-final position, I would think, in the 100 and 200 meters, men's and ladies. So, I mean, it doesn't work for something like the 400 meters. LJ van Sail, for example, who is a very real medal hope in the 400 hurdles. This is not something that can be used for him to give him that extra split seconds difference or that half seconds advantage.
Sure, it definitely can be. What we have is the system basically has two components. So it's got the start blocks that we're able to measure so many different variables about the speed coming out of the blocks and how we can improve the speed coming out of the blocks. So for somebody like LJ, even the 0.5 of a second or whatever he's looking for, it's very possible that we could maybe tweak and get the information from his start that we might be able to improve. And then secondly, when he's running on the straights, we're able to also measure with the laser the speeds that he's running and what his accelerations are like and what his stride rate and stride length is. So yes, definitely an athlete like that. But with regards to medal hopefuls, we're also working with some serious medal hopefuls for the Paralympic sprinters. So we are working with them as well.
All right, you're working with Oscar Pistorius?
At the moment, no, we aren't working with them. I'm not really going to mention names now just because I haven't been able to speak to the coach before this, but not Oscar, no, but we have got some medal hopefuls that will be definitely the 100 and 200 first, second or third hopefuls at the moment.
So I mean, you said that there are plenty of variables that are at play which can be looked at, and individual elements in that can be tweaked so that there is a better pull-off from the starting block. Just to talk us through, because I mean, it's, you crouch down there, you're anticipating the starter's gun going off, and you respond as quickly as you can and get into your stride as quickly as you can. It's as simple as that, but it's not. It's considerably more complex than that.
Yes, for sure. I mean, there's a lot of variables that the start blocks can measure. Now they've got force plates, etc. inside of them. I won't get into too much detail, but what happens in a start is basically once that gun goes off, you've got 100 milliseconds to be able to hear the gun and push off. Anything before that would be a false start. So in essence, you're not really anticipating, because if you were, you would push off just before the gun. But So once you push off, we get measurements such as the force that you push off with your left foot and your right foot. We get your reaction time of your left and your right foot. We get the force that you're pushing against the blocks in your set position, because that's also very important to see if you're in the right position. We get the speed coming out of the blocks, we get the acceleration coming out of the blocks. So we get a whole bunch of variables. And basically in the start, you have a small amount of time, probably the best starters in the world are going at about 330 milliseconds to get out of the block, which is an extremely quick time. But within that time, you've got to be able to push enough force on the blocks to get you out of the blocks at a quick enough speed. We're looking at about people coming out of the blocks in the Olympics are coming out around about 9 to 10 kilometers an hour. So they haven't even taken a step yet, and they're already moving at 9, 10 kilometers an hour. So issues that we can get with athletes, they could be pushing off much more with their one leg and not using their other leg properly, so we can pick that up immediately. We can pick up if they're taking too long to start. We can pick up if they're actually getting out of the blocks too early and they're not getting enough speed out of the blocks. So reaction time, for example, we have a lot of athletes that push off with their right and then their left, which is not ideal, because then you lose a lot of time. So there's many variables just in that little 330 milliseconds that we can really work on and try and get your speed coming out of the blocks as quick as possible.
Absolutely fascinating, the science that is applied to make people go just that little bit faster. Gareth Patterson, thank you very much indeed, a researcher at the Centre for Human Performance Sciences at Stellenbosch University. Going back to the issue of police cells and what happens there, we'll look at a couple of calls on that.